We just talked about balanced forces. Now we're going to talk about unbalanced forces, which are really just the opposite of balanced forces. So with balanced forces, of course, our force is all canceled out. With unbalanced forces, it just means our forces do not cancel out. And so when your forces do not all cancel out, that means you have some amount of force left over, some amount of net force. Remember, the net force is just the total of all your added up forces. If you have a net force, that then just becomes your overall force on the object. In this case of these pictures, a box, for example. If you have an overall force on your object, that means you get a change in motion of your object. By change in motion, we just mean that your object is speeding up or slowing down or changing direction. And as we've already talked about previously, we know that's a change in your velocity. And if you have a change in your velocity, we know that means you have an acceleration. So this is how objects initially get their starting movement. If you have a box, for example, or anything that's just sitting on the counter, it's never going to move until you get some type of unbalanced force acting on this. We'll see this a little bit later on when we get into Newton's laws. In fact, that may have even struck a little memory in your brain about Newton's laws that you've actually learned previously. And so if you apply this unbalanced force, you get the acceleration of this box. And then that gets us into all those things that we talked about before, all the calculations we've done on velocity and acceleration and displacement and all these different things. All that motion originally comes from some kind of a force. And then that motion is typically taken away. The object slows down because of some type of a force. Very often that would be something like air resistance or friction. So in the two examples given on the right over here, you can see the girl is pushing to the right and her arrow is longer, I should say, than the boy's arrow. And so what that means is she is applying more force than the boy is. And so the object then is going to have an overall net force to the right. And if there's a net force to the right, that means there's an acceleration to the right. And if there's an acceleration to the right, we know that the box will start moving to the right. Or you could have both of your people pushing from the same side of the box, from the left side in this case, and now you're pushing the box with equal amounts of force from both of them. That then is just going to double that amount of force because they're both pushing the same direction. So you get a greater net force. This is why if you're trying to move something that's big and heavy, it doesn't make sense to have somebody pushing against you. Obviously, that's going to make it more difficult for you to accomplish your task. So lots of examples of this. Really, anytime something is accelerating would be an example of unbalanced forces. So think of a sled going downhill, right? And if you have a steep enough hill, you pretty much accelerate until you get to the bottom. A ball flying through the air, we'll talk about that example quite a lot as well when we talk about projectiles and stuff. A car speeding up, a car slowing down. There's all kinds of real life examples.